Now members, let us see what happens if they give you capital F of x, then they tell you to get these probabilities and so on, and then how they make the small f of x of the probability density function. Capital F is called the cumulative distribution function, then this is called the probability, the probability density function. So now what we do, this one it can't get three things. You can't get mean using this, you can't get mod using capital F of x, and also the variance, you can't get it. Now, but you can get any probability. If you have this, you can get the mean, the quartile, the median, the quartile, the interquartile using this. So let us go through this. We are going to see how we sketch it also. So they are giving us this, then they are asking us to get the probability of x is equal to 1.5. So if it's the 1.5, we say 1.5 is said in continuous, signs are not so much important. So less than 0.5 is the same as it's in this range. 0.5 is in this range. So below it is that we shall go from 0 up to 1.5. This is what it is. So from 0 up to 1.5. And we said if you have capital F of x, you get this, you substitute in the capital F of x, then minus this one. So this will be f of the upper 1.5 minus f of this lower one. Now, which function do we use in this range? That all these ones are in this interval. Their capital F of x is x squared over 6. So you just substitute directly. This will be now 1.5 squared over 6, then minus 0 squared over 6. And answer will be 375. When we come to 2, so that our 1 less than 3, this will be, you get now capital this 3, then minus f of 1. So we say that, by the way, when you look at this upper one, it's always going to give you 1, so don't press line. So you just read it for formality, but you know that always f of the last three will be 1. Anyway, let us see if it's giving us 1 when we are substituting. So it's that f3 is in this interval, and its capital F of x is this. So we get negative 2 plus 2 into 3, then minus 3 squared over 3. The whole of this is subtract off when we put the 1. Now for the 1 is in this interval, this is its capital F of x. So we have 1 squared over 6. Here you'll get 1 minus 1 over 6, which will be 5 over 6, and you have to do. After getting that, now we come to how we get that small f of x or the PDF. We say, or is our PDF is equal to, we differentiate capital F of x. So it's that we say, but remember we say, when our capital F of x is 0, for the interval of x less or equal to 0, it means that even our small f of x is 0. So that one is done. Then when you come to this, our capital F of x, you see it is x squared over 6. Now to get small f of x for this, we shall just differentiate this capital F of x, which will be 2x over 6, which will be x over 3. Now this one, after reducing by 2 by 2, it's at the interval of 0 less x less 2. Now when I come to this, my capital F of x is negative 2 plus 2x minus x squared over 3. So my small f of x will be, when I differentiate this one I get 0 plus 2 minus 2x over 3 at the interval of 2 less 3. Then when my capital F of x is equal to 1, for what? So now our small f of x, we shall get as 0. For which value when x is greater or equal to 3. Now from there, come and write your PDF. Now this is the probability density function. This is the cumulative density function. Remember the word, when you already see here 1, just know you are dealing with capital F. So now, you draw. Now for the first, now this is where we put 0 elsewhere. Below 0, our f of x is 0. And above 3, it's 0. So we shall put it here 0 elsewhere, as we are going to see. So for this is x over 3 for the interval 0, 2. Then it's 2 minus 2x over 3 for the interval 2. Then this one, so it's giving us 0 below this, and it's giving us 0 above 3. That's why we put 0 elsewhere. And so you have negative your small f of x. Then sketching it, you see this one is a line with a positive gradient, so this one is increasing from 0 to 2. This one is a line with a negative gradient, so it's decreasing. And then you learn from 2 to 3. But let us go through this, through the basics. So, this one is at the interval of 0 plus x plus 2. So, you say when x is 0, our f of 0 will also be 0. And then when x is 2, our f of 2 will be 2 over 3. Then you come for the other one, where we have our f of x equaling to 2 minus 2x over 3. So when x is 2, we have our f of 2 equaling to 2 minus 2 into 4. Minus 3 into 2 over 3, which will give us. This one always is giving you, this one, because this is continuous, the value you get here is the same value you will get here. That's why you see that we are getting 2 over 3. So either I don't waste time always. So when x is 3, our f of 3 will be here 2 minus 2 into 3 over 3, which will be a 0. So you come now and you sketch our f of x. So simple, very easy. You draw your vertical, then your horizontal 2. Then you indicate that this is small f of x, plotting it against the x. So this is 0. We have a 1, we have a 2, then we have a 3. Now when you look at our f of x, is that I have 2 over 3. So it's as is, as starting this one is going to be a third from 0. Then this will be 2 over 3. Then this will be 3 over 3, which is 1 by the way. So now, you see, when x is 0, even this is 0. So you have this. Then you move to 2 and 2 over 3, 2 and 2 over 3, which is there. Then you see, x is going to give you the same thing. Then 3 and 0, 3 and 0, it's there. You get your ruler, then you draw, and then you join these two. You see the way I lines. This one was having a negative gradient. I think it's the negative gradient we're talking about. It's decreasing over 3. Then this one is our f of x equaling to x over 3. And so you are done. When you come now to capital F of x, you start capital F of x, we have when we have on the curves. This one and this one. This is a curve, but with a positive coefficient. This one is a curve with a negative coefficient. What did it say? So my capital F of x first is equal to x squared over 6. When x is 0, so that even my f of capital F of 0 is 0. Then when x is 2, this interval here, I get f of 2 as 2 squared over 6, which will give me 2 over 3. So I'm done with that. Then when I come to the other one, where I have f of x equaling to negative 2 plus 2x minus x squared over 3. This one don't waste time. This value, this 2 here is going to give me the same value as this. So don't waste time there. You just come for the last interval, this one here, 3. You put in a 3, this one you also show you are going to get a 1. Don't waste time there. So now you come and draw. This is going to be my vertical, and this one is going to be my horizontal. So this one is going to be from 0, 1, up to, then I have my 3, this is my x. We are plotting here, capital F of x. Now, you see this one is a curve x squared, and we said whenever it has a positive coefficient, it's going to attain this shape with the minimum point. When it has a negative coefficient of the highest, this coefficient of the highest degree, if it has a negative sign, it's a square, in similar it's a quadratic, it attains a shape of this nature. The one which is not give us the maximum. You saw that from pure math. So now, when I come to the first one, 0 went with a 0. Then 2. Now if I am sketch this is going to be my third. This will be my 2/3. Uniform 3/3, which is 1 by down. So now you see 2 was with 2/3. 2 is 2/3. It's there. You indicate this is that this one is with this. Then this one is with 2. So this curve, because it's having a positive, so I'm going to appear as if it was having a minimum. You show that this is a curve. I think we saw showing that's a curve. Then this one from here went up to 1. So this is R1 with 3. R3 with the 1. It's there. Then from there, you show that now because this one is negative, the last part, this one, negative coefficient for it is going to have any shape. So that's why I'm drawing it now from there. I draw this like this so that it will have, this is where my x is. So you name that this is capital F of x, so that, and then so that you can see it. This is, this one is negative 2 x squared over 3, and there through. So that's it. Remember, that's how we sketch the steps we should work.